Hello, everyone. This video will be focusing on the actor-partner interdependence model within a lavaan framework. So in a previous video, I had walked you all through this initial model right here, where we estimate the baseline actor-partner interdependence model, where we had in a sample of heterosexual couples, and we use male and female reports of depressive symptoms to predict relationship mindfulness, or the extent to which each partner communicates intentionally within their relationship, and they're not kind of on autopilot when interacting with one another. And so this video is going to build upon that by um, uh, allowing us to, and I'm going to demonstrate how to constrain pathways within the actor-partner interdependence model. So from the previous video, you may remember that we found a significant effect for male depression predicting male relationship mindfulness and male depression predicting female relationship mindfulness. And so now we looked at those results, and we examined them, and we saw that they were significant. But now what we can do is we can empirically test whether or not those actor effects are the same, or the partner effects are the same, or we could even test whether or not the actor effects significantly different from the partner effects. So we can do a whole lot of different things, be really creative with our path constraints within the actor-partner interdependence model, and that's what we're going to do here. And so I will scroll down, and so this is going to be the second model. What we have up here is we have our model, and I'm just calling it APIM2. And so what you will notice is that it's very similar to the one we have above, but you'll notice that I have labels in front of the parameters. And so what this is doing is, if there is a common label indicated by A1 and then with a star, um, uh, I have that right here in front of the CESD men predicting relationship mindfulness for men, so that this is an actor effect right here. And so I'm constraining that to be equal with all other pathways that have that same label, that A1. And it so happens down here, I'm constraining that to be equal to the actor effect for the female partner. So I want to constrain that within person effect to be equal across both partners. All right. And so I'm also going to do the exact same thing with the partner effect right here. And so actually what we'll do is I will actually delete that from this model, and we will test that in a subsequent model. And so in this model, we're only going to constrain those actor effects. And the reason I'm doing it one by one is because if we have a significant difference, let's say we have a chi-square of 22, we don't know if it's just one parameter, and we're constraining two parameters at the same time. We don't know if it's just one parameter that's having a huge effect and that's significant, and that the other is actually really, really small and non-significant, or if it's two parameters that are jointly contributing to the significant decrease in model data fit. All right, so I recommend, and I personally remove the paths one by one in order to know exactly where the differences lie. And so down here, you will see we have our fit object. And so we're using SEM. APIM2 is our model. Here is the data. Again, all of this tends to be a fairly standard output. We are now including modification indices, since we will actually have 1 degree of freedom in the model, since we are constraining one of those pathways to be equal. So what is happening with these labels and constraining them to be equal is we are allowing those paths to be freely estimated, but they have to be the same for males and females. So that will give us 1 degree of freedom. If we both constrain both paths to be 0, then that would give us 2 degrees of freedom, but we're allowing there to be an actual estimation of those effects. And so in the previous video, this was checkered, or there's a hashtag. I'm now freeing that up because I want that modification indice. And I'm also conducting a lav test. And this is a likelihood ratio difference test using the chi-square. And I want to compare my first model, which was up here. This is the baseline actor partner model, which is fit2, with my model with one additional degree of freedom, where we have those actor effects constrained to be equal. And so I will actually just highlight everything and we can go ahead and run it. And so we ran two models. So these are the results from the first model. And so we'll kind of breeze by those, and we will scroll down to our new model, this model APIM2, where our actor effects are constrained. And so we have 293 folks, and so we have 12 couples that were list-wise deleted due to missing data. And so there's a couple of things that you can do around that. You can specify full information maximum likelihood, and that will take care of that. But that's for another video at another time. So here, constraining those actor effects to be equal across male and female led to a 1 degree of freedom change, and our chi-square statistic is 11.594. And so the critical value for 1 degree of freedom on the chi-square is 3.84. And so anything above that means it's statistically significant, which means that our model fits significantly worse by constraining those actor effects to be equal. And if you recall in the previous video, the male actor effect was somewhere between 0.3 and 0.4. And the female actor effect was about 0.05. So the male effect was, 5, 6, or 7 times higher than the female effect. So it's not surprising that we find that the chi-square is significant. So people often say, particularly in measurement invariance, that you can use a delta CFI or a change of CFI of 0.01 or less. There's no research that I know of that says you can do the same thing here. So I tend to be a little more cautious around other statistics. The RMSEA is 0.19. So again, it's extremely high. But given that this is a model with very few degrees of freedom, or we know that the RMSEA is biased in those types of models. So I wouldn't give the RMSEA any weight in this, not until we would get 20, 30, 40, or 50 degrees of freedom rather than 1. So let's scroll down to the results. And so what you are going to see is that the male effect and the female effect, you'll see these labels are identical, right? So it's negative 0.247. They are constrained to be equal to one another, all right? What you'll also notice is that now, by constraining the actor effects to be equal, we now actually have significant partner effects, which we did not have in the previous model, which I will actually scroll up to very briefly. This was our original model, where you can see the partner effects right here. So again, CESD without represents women because it doesn't have the underscore M at the end. So the partner effect from female depression to male relationship mindfulness has a standardized effect of 0.047, and the partner effect here was actually highly significant, negative 0.286. And then the actor effect for women was non-significant at negative 0.059. So these were, again, from the first model, and then we scroll down to the second model, and all of our actor effects are significant, and all of our partner effects are significant, which tells us we have something's funky is going on, and we already kind of know what that is, because that chi-square statistic is telling us that that it's not a good fitting model, and that we've actually done harm to the model by constraining those paths to be equal. All right, so this tells us that we need to go back to the drawing board, and we need to allow these paths to be freely estimated. And so when you have a saturated model, you are going to get when you do a path constraint, this is going to be your LRT test, your likelihood ratio test. But when you have existing degrees of freedom and then you're conducting a likelihood ratio test, that's not going to be as helpful. So that's why you would go down here and you would use the likelihood ratio test that I specified here in line 36. But as you can see that the chi-square is identical, and the degrees of freedom are identical to what we found up above. So stated another way, if our model had 20 degrees of freedom and a chi-square of 44 already, then we would have to do some math in order to, some relatively simple math, but we'd have to do math nonetheless in order to calculate this value. So I've always found this to be easier to do just typing in a line of code. All right, so what we're going to do now is we're going to estimate a third model. And so we're just going to go ahead and I'm just going to copy this. And so we'll just create APIM3 and we'll do fit 4. And what we are going to do now is we are going to free up that pathway. So, right, so we're going to remove that. And now we're going to test, so we can, we're going to constrain the partner effects to be equal. And so before we did the actor effects, now we're going to do the partner effects. So the partner effects is our relationship mindfulness for females being predicted by depression for males, and the inverse, relationship mindfulness for males being predicted by depression for females. All right. And so we will want to compare this model, APIM3, to the baseline model, where we have all of the completely saturated model. All right, so we can go ahead and we can run this model. All right. Actually, I will can take a look here and see what we got. So again, we terminated normally, which is good. We have a significant chi-square difference test. So again, constraining those partner effects to be equal significantly reduces the fit of our hypothesized model to what the data are telling us. All right, so this tells us we reject this model and that our original saturated model is more parsimonious and is more accurate than this model. And imposing this constraint of the partner effects being equal up here, that harms the model in a significant way. This will, as I said before, this will be the same at the very bottom when we look at the likelihood ratio test or the chi-square difference test. All right, so we can go ahead and we can look at the parameters just to see kind of what our model is doing. And much like the model where we constrain the actor effects to be significant or to be the same, excuse me, when we constrain the partner effects to be the same, again, we have a very different pattern of results. So again, think back to that original model when the male depression predicted both male and female relationship mindfulness. There's a significant actor effect to their own mindfulness, and there's a partner effect from male depression to female relationship mindfulness, but female depression didn't impact their own levels of relationship mindfulness, nor did it influence male relationship mindfulness. So there were no actor or partner effects for women, but there were both actor and partner effects for men. So what we are doing in this model is we are telling the model the effect from females to males and from males to females is exactly the same. And again, what we found based on the chi-square difference test is that that is not a suitable constraint to put in the model. And we can see that our results differ fairly significantly. All right, so generally, I don't even interpret these results if I have a significant likelihood ratio test or chi-square difference test. So one of the unique patterns that we saw in the first model that we are going to test in our final model right here is that we found evidence for potential a domination pattern. And so what we are going to test now is to constrain that the actor effect to be statistically the same as the partner effect from male depression to male relationship mindfulness and female relationship mindfulness, respectively. And so what we're going to do is, since we have male relationship mindfulness, we want an effect here. So I'm just going to do D1 because this is evidence of a potential domination dyadic pattern. And we also want D1 right here. So this is that actor effect, that within person, within male effect. And here is the partner effect, the effect from male depression to female relationship mindfulness. And I'm going to constrain those to be equal. All right. And so we're going to go through and we're actually going to just change just a few of these numbers since I copied and pasted. And be sure that you choose the right numbers, especially in this likelihood ratio test, to be sure you're comparing the right models to each other. We don't want model with fit.3 and fit.4 in here because they would have the same number of degrees of freedom as fit5. And lavaan would give us an error message saying they have the same degrees of freedom, so they cannot be compared. All right, so we can go ahead and we can run this. And this is again providing, looking at the constraining the actor and the partner effect for males to be equal. And what we see here is that our chi-square difference test is non-significant. So our p-value is 0.06. And so we don't do a whole lot of harm to the model by constraining the effect from male depression to their own relationship mindfulness to be equal to the effect from male depression to female relationship mindfulness. So those are equal in our model, and I will show you what that looks like, and you'll see that in the unstandardized effects. So 0.389 and 0.389, and you'll see lavaan gives you these little labels, which tells you which paths are constrained to be equal. You will see slight differences in the standardized loadings. They're not going to be identical, but generally they're not too far off from one another. And we also want to take a look at what happens elsewhere in our model, because as we've kind of seen a little bit before, when we constrain just the actor effects to be equal across men and women, and just the partner effects to be equal across men and women, we had some really funky things that happened. We saw that both actor and partner effects were significant when we made both those sets of constraints in separate models. And so we want to be sure that we don't have something similar going on here by constraining those paths to equality. Even though it doesn't significantly harm the data, in SCM, we are working with a system of equations. So when you tinker around in one part of the model, it's going to send ripple effects to other parts of your model. So we just want to be sure that we don't come away with any different substantive conclusions. And so it looks like here we see that the effect from female depression to male relationship mindfulness, it did go up quite a bit. It probably went up by 25 or 30%, but it is still non-significant. So we would need to evaluate if we're going to write this up for a manuscript, whether or not that is an acceptable change in the parameter, and we would use theory to adjudicate whether or not it makes sense to have these path constraints. All right. And so we will continue to scroll down and we will again look at the R squared. So you'll remember in that first model, I believe it was around 18% for males. And so our R squared actually went down a little bit because that actor effect, the effect from male relationship mindful or male depression to male relationship mindfulness, if we go back all the way up to the top, it's going to be slightly higher than the partner effect. So we see here that the actor effect is right here with a standardized loading of 0.40. And here we have a standardized effect of 0.29. And so we did not, again, these were not significantly different in our model. But as you can see that practically, that if we just think about the magnitude of those effects, they seem to be quite different. Like when I look at, is 0.40 really different than 0.29? And in my mind, I say yes. So we just might not have the power. We might don't have enough dyads in order to accurately detect this difference. But if we were to add another 100 dyads, for example, that test might become significant. So again, I think it is potentially reasonable, at least in our model, to retain that. But do I think that's necessarily what's going on in the population? Not necessarily. I think that I would say that that constraint is, and it's marginally significant down here, that likelihood ratio test, or marginally non-significant, but it's approaching significance. So this is where we'd have to do some theoretical thinking based on, do we really think that's true? That the actor effects and the partner effects are exactly the same? Or are we actually more comfortable, saying that they are different and having a theoretical justification for that? And that's again part of the work. So hopefully this has been helpful in going through and testing different model constraints within the actor partner interdependence model.